All right. So before we move on or move any further, okay. So I want to just have a little bit of a summary here, guys, girls. I want you listening up here. You're doing a great job so far listening, and I want you to continue. I'm giving you a little bit of a summary for the rules here, okay? When we are simplifying radicals, in summary, we have dealt with adding, subtracting, multiplying, and dividing. Okay? Adding and subtracting and multiplying and dividing have two separate rules. With adding and subtracting, the radicand must, yes, be identical.
What is this?
These are rules.
It's just a rule. I'm just summarizing. Okay, I'm giving you a little bit of a summary page here. So, for example, I can only add these two together because they have an identical radicand. Okay, makes sense? That works for adding, and it also works for subtracting. For multiplying and dividing, you multiply radicand by radicand, coefficient by coefficient. For example, 2 root 3 multiplied by 4 root 5 gives me 8 root 15.
And they have to have a similar index, right?
Yes, good point. You can't multiply them if they have one's square root and one's cube root. Okay? And that's part of the reason why I say identical here too, is you could have root 3 and cube root of 3. You can't add those together because they're not identical. Okay? Good point. Does that make sense? That help?
Are there some more rules?
No, that's it. Those are the only two rules for adding and subtracting and multiplying and dividing.
I mean, way too big a shortcut.
Okay? Can I move on, Skylar?
No.
Okay, next we're going to rationalize. Next we're going to rationalize the denominator. We did a little bit of that before, but we're going to actually throw a little bit of a curveball. Okay?
What were we doing?
Rationalizing the denominator. We did this already, but there's a new situation that I have to show you.
Okay.
You can't wait to call this.
Okay. Skylar, good?
No.
Come on.
I'm going as quick as I can here, but
Hey.
lag. Just wait. 8. Okay, now go ahead.
It's like the circle.
Hey,
We're not all freaking buffering.
Please wait. Okay. Rationalizing the denominator, we have done in the last example, or last unit with trig, where we have 1 root 2. The simple version, the simple rule I gave you was we're only multiplying by the issue, or by the problem. For the first example of 5 divided by 3 root 11, which number is my problem number? Root 11 is my issue. It's on the bottom. I don't have to multiply it by 3 because the 3 coefficient is fine. We don't like having a square root on the bottom. So, the simple rule is, if I don't like something, change it and deal with the consequences. How I change it is it's actually called multiplying by the conjugate, but I'm just going to say just multiply it by the problem. Okay? My problem's root 11, I'm just multiplying the top and the bottom by root 11. What is 5 times root 11? 5 root 11. 3 root 11 times 11. The 11's multiplied together to make 121. What's the square root of 121?
11?
I'll stop cursing, I'm sorry.
YouTube is going to know that Taylor Henley curses like a sailor.
Well, now that you said my name,
I
you
know.
will.
3. Okay, sorry. So 11 times 11 is 121. Okay, square root of 121 is what?
11.
11. What is 3 times 11? 3 times 11 is?
3.
We did it. Fantastic.
What?
How do I check to make sure my answer is right?
Why is it just over 33? Now I'm
Not, Mr. Dillon, I don't know. Can you explain it?
Why?
Where did I go wrong? Instead of getting mad, you just say, Mr. Gilly, I don't get it.
Wait, where'd you get 33?
Okay, how did I get to 33? Good question.
I know.
How?
Oh, 3 times 11.
Don't you have to multiply
Let-
3 by root of 11 though?
Can we time out? 1 second. Let's all do this together, okay? I'll give you the steps. Can we time out for?
I'm buffering.
Okay, in order for me to combine this, 3 times 1 is just 3, right? I'm multiplying, right? I can only multiply coefficient by coefficient, radicands by radicands. 3 times 1 is just 3. Well, what's 11 times 11? 121. Can I simplify anything in the top here?
No.
No. So I'm going to set that equal to 5 root 11. However, 3 and 1, the square root of 121 we just established is 11.
How come you can multiply 3 by 1 though and not have to multiply it by the root of 11?
What did I just say? Coefficients by coefficients, radicands by radicands. That's the rule that literally we just talked about. Right?
Yep.
Make sense? If it was 3 plus root 11, I would have to do both of them, but because it's just one term, which is actually what we're going to talk about next, so stay tuned, okay? We're only dealing with one term. Stay tuned. Yeah. Because I have 3 times 11, then I can make it 33. Does that help?
Yes.
Are we in a better state now?
No, I'm still not in a good state, but that helps me a little.
Okay. The only other thing that we can talk about is if I have an index of 3, okay, that has to be included in my coefficient, okay? So if I'm multiplying this one, it has to be the cube root of x divided by the cube root of x.
Oh my
This
God.
becomes 5 cube root of x and 8x. Okay?
I feel like with my liver's failing. My stomach hurts so bad.
Are we good with that? Yes, no, maybe? No? Did I lose you in this one too? Okay, that's
I
fine.
actually feel like my liver.
This one here, the top numerator, guys, girls, the side conversation stop. If you are not sure what's going on, just tell me to slow down, okay? Or tell me to explain it. This is fine. 5 times cube root of 5 of x. I can't do anything with that other than to combine them, right? This 8 cube root of x times cube root of x. 8 times 1 is 8. But the cube root of x is actually, I'm timesing it by 3. Yeah. So it actually becomes this, and that combines to make just 8x, because I have 3 groups of that. Did I just screw that one up at night? Let's forget about that one for now. I'll deal with that later, okay? For now, let's review, let's make sure that we understand the square root of rationalizing that denominator. I'll come back to this later, okay? I want to get through the rest of it and just make sure I'm not screwing that up. Jake, wake up. Okay? I'm going to go back to that when I give you an example.
Okay, how can we erase that?
How come?
Yeah.
I need to make sure that this cube root, I can just do that. I need to make sure that I'm giving you the math.
Just
Not
make
screw
up
it.
your own rules, Mr. Dillon.
I don't want to make up my own rules.
It's good. I trust you.
That's right. Okay, so now let's go into, these were rationalizing denominators with one term. Guys, girls,
That's my total.
I'm going to split these up. I need you focused up here, please.
Scott, can you give me the clock again? No one's allowed to ask, but it's not really.
What?
Why am I not just here?
He acts like that's the worst thing in the world. Like it's that. And you like really show him.
Jake, they go out of my way. Grab your claw.
Are we good?
No.
We need to take like a really break.
I'm far from good.
Okay.
You know what? Keep it.
I'm giving you guys